All right, today we are going to start looking at the law of sines and we will continue with the law of cosines. So last class, everything was being a right triangle. Well, today they are not going to be right triangles. They're going to be what we call oblique triangles, okay? Which means two options here. They can either be a triangle that have all acute angles, so all the angles are less than 90, or you could have a triangle that has two acute angles and one obtuse angle. We still are going to be solving the oblique triangles, finding all the lengths of the sides and measures, just like we were with right triangles. It's just that we can't use right triangle trig. So today we're going to use law of sines to do it. Next time we'll continue with law of cosines. So there's going to be some times in here that you're probably going to want to pause the video to be able to make sure you can do the work in your calculator and get the right answers. And I highly suggest that you are pausing as you go through here what I would normally give work time in class. So go ahead and pause to take care of those things. So the law of sines says this, that we can set up different proportions. So my equal signs for some reason are not coming through on all this stuff. So on here I have sine of A over A equals sine of B over B, which equals sine of C over C. Or you can flip-flop it and put the lengths on top and the angles on bottom. It doesn't matter as long as you stay consistent. You're going to see most of the time that I use this bottom one, not for any reason that it's just like comes natural to me to put the lengths on top and the sign on bottom, but you get the same answer no matter which way you do it. So there are four cases for oblique triangles. Today we're going to look at two of them with the law of sines. The other two cases will be our law of cosines next class. So for case one, you could be given one side and two angles. So you could have side angle angle or angle side angle. Case two, you are going to be given a side angle, two sides and one angle. So we're going to look at both situations and using our law of sines. So case one would just be here, like where you're given an angle side angle. Okay, you would never be given like angle side and then another angle over here. They have to be connected. Or you could be given side angle angle, so side angle angle of some kind. That's what we're going to look at first. Also, just a reminder that the three angles of our triangle have to equal 180 degrees. We talked about that last time, but just a little reminder. So we're going to use this knowledge plus the sine form or the law of sines formulas that I just gave you to solve some triangles. So we just have some examples that we are going to be working through as we do this. So the first one, we have our triangle, and it gives us some pieces of information. I think it's easiest if we would draw the triangle. So let's just begin by drawing a picture. Your triangle doesn't have to look just like mine, but it puts the information in that we need. So I know that little b is 76. It has to be opposite of angle B, which I don't know. Angle A is 50, so little a goes across from it. Angle C is 33.5, so little c goes across from it. So we know that we need to find, if we think about what we need to find up here, we need to find big B because I don't know it. We need to find little c because we don't know it, and little a because we don't know it. Well, what's the easiest of all those to find? The easiest would be this third angle because we know the three angles have to add to 180. So let's find the measure of angle B. So remember, our three angles have to add to 180. I know two of them. I know 50 and 33.5. So if we do just 180, subtract 33.5 and 50, we get our 96.5. So we know capital B is 96.5 degrees. Make sure you're labeling things if you know a label. So now we know our B's up here are 76 and 96.5. So we can use that because we know now all of our B information right here. Then we need to find A and C. So we're going to set up two separate proportions. We need to find A and we need to find C. So to find A, we'll set up our proportion with using our A information and our B right here. So we don't know little a, but then we know that sine of 50 equals our little b over sine of our big B, which was 96.5. And now it becomes solving a proportion. So remember, when you solve a proportion, we cross multiply, right? So I would have a sine of 96.5 equals 76 sine of 50. Then you would need to divide by sine of 96.5. So our A is going to be 76 sine of 50 over sine of 96.5. Make sure your calculator's in degrees. So notice you cross multiply the two that aren't connected with the a, divide by the one that would when you're writing it out. So in your calculator, pause if you need to, plug this into your calculator, make sure that you can get the right answer. You should get 58.6. So now we know our little a. So up here, if you think about it, we know little a is 58.6. Now we need to find little c, so we're going to set up another proportion. C over sine of 33.5 equals our 76, our b over sine of 96.5. So c, you'll get used to doing this, is just going to be 76 sine of 33.5 over sine of 96.5. Again, working it out in your calculator, you should get 42.22. We're going to be rounding everything to 2 decimal places. That's what I'll ask you to do on a test, so I recommend just getting used to that now. So now we know our little c is 42.22. We know all 6 pieces of information. 3 are given, and we found 3, so we are good to go. So moving on to example 2, again, we're given pieces of information. We're given capital A and little a, so we're given both of these. So we're given capital B, so I don't know little b, I don't know little c, and I don't know capital C would be missing pieces of information. If we were to draw our triangle with what we know and where everything is set up, and then we will need to write out our formulas for what it is that we are doing. So again, first thing we want to do is find our angle right here. So we have 180. These two add 30 and 70 to 100. That means this is going to be 80 degrees, right? So we know our angle C is 80. So if we think about everything that we know now, find our measure C, that's what I just did, is 80. So then we have our angle C. So this is all the information we know so far. We still are missing. I always like to write these little boxes. I think they help with our A, B, and C and what we're missing for information. So now we need to set up our situations or our portions to solve for little b and little c using our law of sines. So this one has a sign on top and the measurement on bottom. Remember, that means the same thing. You can do it either way you want. Okay, so I'm just going to show you on this one using it the other way. So here I would have sine of A over little a equals sine of B over little b because I know both my a's. So that would be sine of 30 over 5 equals sine of 70 over b. We need to solve for this b down here. So if we solve this, this would be b equals our 5 sine of 70. Multiply the 2 together without the b. Cross multiply. Divide by the one that is the same as with the b, so sine of 30. So then if we work through this, you should get b equals 9.4. Again, make sure you're getting it in the calculator. Questions on setting them up, let me know. So then I know my b up here is 9.4. Then I need to find c, so we're going to have sine of 80 over little c equals sine of 30 over 5. So our c would be 5 sine of 80 over sine of 30. Working c out in our calculator, you should get 9.85. So 9.85 would go up here. Again, we know all 6 pieces of information, which is what we need to have at the end. Make sure that we have all of those correct. Okay, let's look at another one here. So I have information. I have my triangle. I know A is 20, B is 60, C is 12. I've drawn my triangle, have it all figured out right here. Okay, what do we know? I know capital A is 20. I know capital B is 60. I know little c is 12, so I need to find little a, little b, and capital C, our angle. Well, the angle C is the easiest to find. Again, 20 plus 60 is 80, so it has to add to 180, so I know my C is 100 degrees. And then we can use this, we know our C's, to solve for A and B. So again, I would have A over sine of 20 equals 12 over sine of 100. And then for b, I would have b over sine of 60 equals 12 over sine of 100. So again, working this out, a would be 12 sine of 20 over sine of 100. We plug it into our calculator, so little a is 4.17. So I know this one up here. B is going to be 12 times sine of 60 divided by sine of 100. Again, working it out in your calculator, 10.55. I would definitely make sure that you are getting these. Pause the video. Make sure you're getting that in your calculator and having the right answer. Okay, example 4 is just like what we were looking at right here, except that I want you to solve it on your own. So pause the video, solve it all out, because the next slide is going to give you your answers. I'm going to tell you up here, you know 56 degrees is capital A, C is 24, and little a is 12. So see if you can solve for our 3 unknowns. Pause, solve. So once you're back, your answer here, you should have capital B is 100, little b is 14.3, little c is 5.9. And then we're going to move on to case 2. So the law of sines, again, has 2 cases. What we looked at before was just our case 1, where we knew 2 angles and 1 side. Now we're going to know 2 sides and 1 angle. These are a little more difficult, and there's more options. So when we know 2 sides and 1 angle, there's 3 possibilities. We could get 1 triangle like just what we've been looking at, and everything works out and nothing more needs to be done. It could possibly be a right triangle. Either way, you're getting 1 triangle. You could get no triangle, which means when you try to solve, your side length isn't long enough to come all the way down and connect to make it. You could get 2 triangles. It could be that angle could come, and it could be an angle here. It could be an obtuse angle, or it could make an acute angle. So there's 2 different angles it can make. So it's a possibility you have 2 triangles. So you always have to check for the 2 triangles. You'll know right away that if you have at least 1, and you'll know right away if you have none, which we're going to go through with our examples. So let's take a look at an example here. So here we're given some information, equal signs in here again. We want to solve when I know that B is 5, C is 3, and capital B is 30. So if I draw my picture, I'm going to fill in over here what I know. I know this is 5, 3, and 30 degrees. So I can't just find a 3rd angle like I did before when I knew 2, because I don't have 2 angles. So the first thing we want to do is take our information, and we're going to want to use this right here. I know B and 1 C, so I need to find the unknown C. Okay, so when we do this, we're going to have, and I am going to go ahead and put my signs on top again. It doesn't matter, so pick whichever one you like or switch back and forth like I am. So I would have sine of 30 over 5 equals sine of C, because I don't know it, that's what I'm solving for, over 3. So when I'm solving for an angle, it's a little more difficult. Sine of C is going to equal 3 times sine of 30 all over 5. Think about cross multiplying. The 2 aren't not connected. Divide by what is. But to get the angle, remember we have to use the inverse in our calculator. So to get angle C, you're going to have to do the inverse sine of all of this. So it's inverse sine of 3 sine of 30 over 5. Highly recommend you work on calculating that and how you put it in the calculator. So when you do this, you should get 17.46 degrees. So my C up here is 17.46 degrees. So I know I have 1 triangle for sure with this right here. What I need to do is test and be like, okay, well, am I going to have another triangle? So it's possible that we have 2 triangles. So we need to now check for a second triangle. So to check for a second triangle, you take 180 degrees and subtract the value you just got of 17.46. So when I do that and I subtract them, I get 162.54. So remember, all 3 of these of our angles have to add to 180. This is why I did this. And now I know that another possibility could be 162.454, but can I do that? To figure it out, take the angle given to you. Well, it told me that one of them is 30. So if I add 30 to what I just got, that gives me 192.54. Well, I can't be over 180. This is greater than 180, which isn't possible because the angles have to add to 180. So there is no second triangle. So the rule is if this is bigger than 180, there's no second triangle. We're just going to finish finding what I need up here and we're done. If it's less than 180, there is, and we'll do an example of that so that you'll know, and we'll also do an example so that you know that there is not anything else. Okay, so now that I know I only have one triangle, I don't have to worry about this second triangle, I can go ahead and just find the rest of our stuff. So I'm going to erase a little bit on here so that I can come back and get some information that we need. We know there's not a second triangle. So what we want to do now is we need to solve for our little a and our big A. So we can solve for big A real quick, right? Because we know that 180, we can find this angle, do 180 minus 30 minus your 17.46, and we can find out right away that our big A is 132.54. So big A, 132, I'll write it out here so you can read it better. That was just 180 minus 30 minus 17.46, so that's one thing we know. Now we can use our law of sines. So I know that sine of 132.54 over little a, because I don't know it, equals sine of 30 over 5, and solve. So A equals 5 sine of 132.54 divided by sine of 30. Again, put that into your calculator and you should get 7.37. So now we have all of our pieces of information. Okay. So that's an example of one triangle. So sometimes we'll have to find information and we will find it by using an application. So sometimes it might not ask you for everything, it might just ask you for one thing. So in this case, it's telling me two stations are on an east-west line 110 miles apart. A forest fire is located at a bearing of north 42 degrees east from a western station A and a bearing of north 15 degrees east from B. So a picture. Sometimes pictures will be given like this and sometimes they won't. So just think about what this is. It tells us that two stations are 110 miles apart, right? So that's this down here. My two stations, A and B, are 110 miles apart. There's a fire, so we have our fire out here. So north 42 east means that if you think about this, our north, we have our north and our east, right? So north 42 means I start north and then I have to go east 42 degrees. So same thing with my north 15 is over here. I have my north, I have my east, and I know this is 15. Okay, so now know that northeast is a 90-degree angle. So if this is 42, this is going to be 48 because it has to add to 90. If I know this is 90 and this little part is 15, then I know this whole angle right here is 105. All three angles have to add to 180. So if I know these two, then now I know this angle up here is 27. It was a really bad 27. This angle right here is 27 degrees. It wants to know how far is the fire from the western station. Well, if I think about A and B, A is on the west side, so I'm going to say that I want this right here. I want this line right here from station A to station C. So to do that, we can set up a proportion now because I know I need B, and it's across from the angle that's 105 degrees. Then my only side it gave me is this 110. And I know that it's across from our angle up here that we found of 27. So now we can plug this into our calculator. So B equals 110 sine of 105 over sine of 27 plug it into our calculator, and we would get 234.04 miles. Okay, and that's what it's asking for, because that's all it wanted was B. We don't have to do any more work. Okay, moving on. Example, whoops, we already did all these, so not worrying about that. That's still number 6. I did it all already. All right, here is example 7. We want to solve our triangle. We know little c, big B, and little b, so side-side angle. So what I need to find is big C, and I need to find little a and big A. So if I know my two B's and I know C, that means that I can find angle C to start with. So I would know that 5 over sine of C equals 3 over sine of 50. So again, working through this, sine of C equals 5 sine of 50 over 3. So again, we need an angle. I have to find the inverse. So C equals the inverse sine of 5 sine of 50 divided by 3. If you put this into your calculator, it is going to tell you error. That means this is not possible. You can't do it. So there's no angle that exists that makes that true. So in this case, there is no triangle. No triangle can be formed, so there's nothing else we need to do. No triangle. If you try to find your angle and you get an error, that means you don't have a triangle. So then moving to example 8 here. Again, we have our 3 sides, or our 3 pieces of information, little b, so we know side B, angle B, and side C. So we could put all this in our information. You can draw triangles. Drawing triangles is not as important, except in applications is where you really want to make sure that you know what's going on. Otherwise, it's just giving you information and solving for the unknown. So here again, I need to first start with angle C right here. Okay, so I know B's, we'll find all this, so I know 8 over sine of 45 equals 10 over sine of C. So again, sine of C equals 10 sine of 45 divided by 8. Solve for C, you have to do the inverse, so inverse of 10 sine 45 all over 8. So I get C here equals 62.11 degrees. So I know I have at least one triangle because I got an answer right here. So now I need to check for a second triangle. Okay, whenever we get one answer, we automatically have to check for a second triangle. So when I check for my second triangle, remember that takes 180 minus 62.11. And if I do that, I get 117.89 is another possibility. Well, to see if it works, take the angle they give us. They give me 45, add 45 to this. So that's going to give us 162.89. This is less than 180. So there is a second triangle. So since it's less than 180, so 2 triangles. So that means that I have to solve a triangle up here where my C is 62.11 degrees, and then I need to solve another one where it is 117.89. So we're going to have to do this twice. So when we have to do this twice, we'll start here. I'm going to erase a little bit again. We already found our C. So I'm going to work first here with this being what we found, 62.11. So we're going to find everything. We know that's one of our angles. I'm going to keep this second triangle for over here for just a minute. So now with knowing these 2 angles, I can find angle A. So if we take our 180 and subtract 45 and 62.11 to get angle A is 72.89. Then we can solve for little a, so I'd have little a over sine of 72.89 equals 8 over sine of 45. So without me writing it out, take a second, see if you can solve. I have to put this in my calculator, I don't have the answer, so I'm going to work through it real quick also. So here I got that my a is 10.81. That's one triangle. This is my first triangle. Right? But because I know that I have two, I now have to work another one. So this is my first triangle. I have to do all this again, knowing now that my C is 117.89. So my triangle 1, we just did everything, and we found our A up here to be, what was it, 10.82, 10.81. So now that was my triangle 1. Now I need to find triangle 2, so I have to do everything again. So I have to find my big A is 17.11. So I had everything, and this time I was using, whoops, this is 117.89. 17 of 11, and then again we need to find this little a, so a over sine of 17.11 equals 8 over sine of 45. Solve for our a again. And I got 3.33 when I plug that one in. So sometimes there is one triangle, sometimes there are no triangles, and sometimes there are two triangles. Make sure you know how to do that. If you need help on something with that, please come and see me so that I can get you straightened out during seminar on how to do that and what that all means. Okay, we have one more example, a word problem here, and I left a picture on your notes of this one. This one has, the figure shows a 1,200-yard sand beach, so we have that down here, and our oil platform out here. The angle made with the platform from one end of the beach is 85. We have that. 76 is our other. Find the distance of the oil platform to the nearest yard from each end. So I actually want to find both distances. Since this one's labeled angle A, I'm going to put little a here and little b here. And we need to solve for little a and little b. So we need to know our angle C right here. Didn't ask for it, but I need it to set up my proportions. So if I solve 180 minus 76 minus 85 is 19. And then we can set it up. So if I solve for b, I would have b over sine of 85 equals 1,200 over sine of 19. I also need then to solve for a. So a over sine of 76 equals 1,200 over sine of 19. At this time, you should be able to solve for both of these without me writing things out. If you need extra help, please come see me. So if you plug these into your calculator, you should get that B is 3,671.84 yards. Make sure you're labeling their word problems. And my A is 3,576.38 yards. Okay, word problems need to be labeled. So make sure that you are labeling, make sure you're understanding if you have 0, 1, or no triangles. You have a worksheet for your homework. You will not have a quiz next class. We will wait until after we do law of cosines. So if you have questions, please come in and see me during seminar.